All right. Um, Thank you very much, and welcome to College Algebra. Today we will be discussing section 2.8, uh, which talks about inverse, which talks about distance and midpoint formulas and circles. So this is section 2.8, and we are discussing um, distance and midpoint formulas. All right, so let's between 2.8 distance and midpoint formulas. And also circle. Because let's start with a distance formula. So the distance d between the points between the pair of points x1, y1, and x2, y2 in the rectangular coordinates. In the rectangular coordinate system. This d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Right, so example, let's look at this first example. For example 1a, and it says find the distance. Let's do it on the next page. Yeah, example 1a. Let's find the distance between find the distance between -1, -3, and 3 express express the answer in simplified. So the answer is simplified radical form. Then round to two decimal places. All right, so the distance is d is equal to the square root of x2 minus x1, so x2 is 3, minus x1, which is negative 1, all squared plus y2, which is 3, minus y1, which is negative 3, all squared. So this equals to the square root of 2 plus 1 squared, um, 2 minus negative 1 is 2 plus 1, so 2 plus 1 squared plus 3 plus 3 squared. So this gives us square root of 3 squared plus 9 plus 6 squared. Because of the square root of 3 squared is 9 plus 6 squared, that is the square root of 45. And so 45, square root of 45 is equal to the square root of 9 times 5, which is the same as 3. Square root of 9 is 3, so 3 square root of 5. And in decimal form, in 2 decimal places, about approximately 6.71. All right, so this is the distance between the 2 points. Let's look at another example. Another example on distance, finding the distance. So this should be our example 1B. And we have to find the distance between the points. Find the distance between the points -3, -7, and 3, -6. So B is equal to H2 minus H1. So H2 is 3. So 3 minus H1, which is -3, squared plus y2, which is -6, minus y1, which is -7 squared. And so this equals to the square root of 3 plus 3 squared plus -6 plus 7 squared. So this equals to the square root of 6 squared plus 1 squared. So this equals to the square root of 37. So the square root of 37 is our discount. We can express the square root of 37 also in the decimal. In the square root of 37 expressed in a decimal is 6 points. In two decimal places, approximately 6.08. So this is the distance between these points. Let's look at a third example. Um, so example 1C. Is find the distance between the points 7, third, 1, 7, and 1 third, and 8 divided by 7. All right, so D is equal to the square root of x3, which is 1 third, minus x1, which is 7, divided by 3 squared, plus y3, which is 8, divided by 7, minus y1, which is 1, divided by 7. Right. So this equals to the square root of 1 third minus 7 third is negative 6 divided by 3 plus 8, 7 divided by 1, 7 is 7 divided by 7. So, so this equals to negative 6 divided by 4 is negative 2. So negative 2 squared and negative 2 squared plus 7 divided by 7 is 1 squared. So this equals to the square root of negative 2 squared is 4 plus 1, so this equals to the square root of 5. And the square root of 5 can also be written in decimal form as 2 for in 2 decimal places will be approximately 2.3, 2.24. About 3 decimal places. All right, so this is how we find the distance between a pair of points. Let's look at the midpoint formula. The midpoint formula. The midpoint formula. All right, so if we consider a line segment, whose endpoints are H1, Y1, and H2, Y2. The coordinates of the segments reference. So the segments midpoints. Midpoint are H1 plus H2 divided by 3, comma Y1 plus Y2 divided by 2. Okay, so those are the formula for midpoint. The x coordinate, sum of the x coordinates divided by 2, and the sum of the y coordinates divided by 2. All right, so let's look at an example. So this should be our example 2. And it says find the midpoint. I find the midpoint of the line segment. Find the midpoint of the line segment here. The endpoints 1, 2, and 7, and 8, 3. All right, so the midpoint formula is x1 plus h3 divided by 3, y1 plus y2 divided by 3. So this equals to 1 plus 7 divided by 2 over 2 minus 3 divided by 2. So this becomes 8 divided by 2 over negative 1 divided by 2 equals to 4 and negative 1 divided by 2. So this is the midpoint between these for this line segment. All right, so next thing is we have to look at circles. So definition of a circle. Definition of a circle. Yeah. Um, so a circle is a circle is a set of all points in a plane that are equidistant from a fixed point called a center. The fixed distance on the circle is called a radius. So a circle is the set of all points in a plane that are equidistant from a fixed point called a center, and the that fixed distance on the circle is called a radius. All right, so we have a standard form for the equation of a circle. So let's try to write that down. Let me write the definition of a circle down. So a circle is a set of all points. Circle is a set of all points in a plane. In a plane that uh, that are equidistant from a fixed point called a circle. The fixed point, the fixed distance on the circle. And the circle is called the radius. All right, so we have a circle. The distance from the center of the circle to any point on the circle is called the radius. All right, so there is a standard form of an equation of a circle. Let's go to that. So the standard form of the equation of the circle The standard form of the equation of a circle. The standard form of the equation of a circle changes h a a radius r is x minus h squared plus y minus k squared is equal to r squared. All right. So this is a general form of an equation of a circle. Let's look at an example. So this will be our first example. Example 3a. Let's call this example 3a. And it says, write the standard form of the equation of the circle. The equation of a circle with simple field example 0, negative 6, and radius with the center 0, negative 6, and radius 10. All right, so the general form of the equation is x minus h, and h here is 0. So x minus 0 squared plus y minus k. And here is negative 6, y minus negative 6 squared is equal to the radius squared, which is 10 squared. So this becomes x squared plus y plus 6 squared is equal to 100. That becomes the equation of the circle. All right, let's look at another example. Uh, Example 3b. This is right, the standard form of the circle with the given center and radius. The given center and radius. the center is 5 negative t, and the radius is equal to k. All right, so our formula is x minus h squared plus y minus k squared is equal to r squared. So x minus h here is 5, so x minus 5 squared plus y minus k is negative t, so y minus negative t squared is equal to r squared, which is k squared. So this becomes x minus 5 squared plus y plus t squared is equal to 9. So this is the general form of the equation of a circle with center 5, negative t, and radius 3. All right, so let's look at another example where we are given the equation of the circle and we have to pick the radius and the center from it. So this will be our example 4. And it says find the center find the center and radius of the circle. Find the center and radius of the circle. Of the circle, this equation is x plus 3 squared plus y minus 1 squared is equal to 4. All right, so the general form of an equation of a circle is x minus 8 squared plus y minus 3 squared is equal to r squared. So if we compare the general form to this form that we are given, you can rewrite this form that we are given as x minus negative 3 squared plus y minus 1 squared is equal to t squared. If we compare this to the general form, then we can tell that the center h is negative 3, the center k is 1, and the radius is 2. So the center HK equals to negative 1, and the radius equals to 2. All right, so if I will write, um, this I will write, we obtain the center and radius from the general form. All right. So okay, this is how we find the general form. So let's look at another example that says the general form of the circle is x squared plus y squared plus bx plus ey plus f is equal to 0. Let's look at how, if we are given example 6, let's look at another example where if we are given, okay, this is our example 6. It says write in standard form, write in standard form. Write in standard form and graph. Write in standard form and graph x squared plus y squared plus 4x minus 4y minus 1 is equal to 0. All right. So to write this equation in standard form, this is how we are going to proceed. So let's look at how we do it. So we're going to write this as x squared plus 4h plus y squared minus 4y is equal to 1. And next we can add 4. We can add 4 in each of these parentheses. So we have x squared plus 4x plus 4. And we add 4 on the right hand side. And this plus y squared minus 4y plus 4. So you have the plus 4 on this side again. All right, now if we factorize the first parenthesis, we get x plus 3 squared. And if we factorize the second parenthesis, we have y minus 3 squared. And this equals to 9. Right? Factorization of this first parenthesis is x squared plus 2x plus 3x plus 4. So if we group these two, we can factor 2x out of the first parenthesis, so 2x times x plus 3, plus we can factor 2 out of the second parenthesis, so 2 plus x plus 3. So this becomes x x plus 3. So you can factor x out of the first parenthesis, 3x. This x. So this becomes x plus 3 times x plus 3. And so that's how we get x plus 3 squared. And the second parenthesis, we can do the same thing. This is and then this second parenthesis, we can factorize it similarly as y squared minus 2y minus 2y. The negative 4y is the same as minus 2y minus 2y plus 4. So we can factor y out of this first parenthesis, so y times y minus 2. We can factor negative 2 out of the second, the negative 2y minus 2. So this becomes y minus 2 times y minus 2. This is y minus 2 squared. So we can, given this form, we can use factorization by adding numbers to the left and numbers to the right to obtain the equation of the circle in standard form. Okay. So the next thing we want to look at is converting. The next thing we want to look at is converting the general form of a circle equation its standard form. Um, Converting the general, so first of all, the general form of the equation of the circle. We have the standard form of the equation of the circle. And we have the general form of the equation of the circle. So the general form is the general form of the equation of the circle is x squared is x squared plus y squared plus dx plus dy plus f is equal to 0. So this is the general form of the equation of a circle. All right, so let's look at converting the general form of a circle's equation to the standard form and graphing the circle. So let's look at converting the general form of a circle. The general form of a circle equation. The circle equation to standard form. It's standard form and graphing the circle. All right, so this will be our example. If you our example 7, it says write the standard form and graph. Write the standard form and graph. X squared plus y squared plus 4x minus 4y minus 1 is equal to 0. All right, so first we need to write this in standard form. And in the previous example, we wrote this in standard form. We said this is x squared minus plus 4x plus y squared minus 4y plus 4y minus I think this is supposed to be minus 9. No, minus 1. Minus 1. Okay. Is equal to 1. And we added 4 here. X squared plus 4x plus 4 plus y squared minus 4y plus 4. So we added 4 here and 4 here. So that makes it, we add those three 4s together, plus 4 plus 4. And so when we factorize this becomes x plus p squared plus y minus 2 squared is equal to 9. So this is now, so the equation is in standard form. So we've converted it from the general form. So this is the general form. This is the general form into the standard form. Converted it from the general form into the standard form. Into the standard form now. All right. So now from the standard form, we know that the center, if we rewrite the standard form this way, let's write the standard form this way. So this standard form can be written as x minus negative 2 squared plus y minus 2 squared is equal to 3 squared. So from here we know that the center HP is minus 2 and positive 2, and the radius is 3. So we know the center, we know the radius, so we can graph this circle. Okay, let's graph this circle now. Okay, this is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. It's negative 1, negative 3, negative 3, negative 4, 85, and this is negative 1, negative 3, negative 4, negative 4, negative 5. All right, so the center is at negative 2 and positive 2. So the center is here, negative 2, and the radius is 3. So the radius is 3 from negative 2 to this point, somewhere this point is about negative 1 is about the distance of 3. So the distance of 3 is from here, from this point to this point is about a radius of 3. From negative 2 to negative 5 is about a radius of 3 again. So our circle will look something like, and also above here will be so our circle will be a rough straight, will be something like rough scale should be something like this. All right. So this is how we graph a circle from the general form to the standard form. All right. So we'll bring our discussion on 2.8 here to an end, and we shall begin 3.1, section 3.1 in the next video. All right. Thank you.